Today I'd like to introduce you to the chain rule. The chain rule, as it says above, is a technique for taking derivatives of composite functions. Remember, composite functions are functions that have multiple levels, and we take the derivative of these composite functions by first identifying the different levels and then taking the derivative of each piece separately. Quick review, since you've already looked at identifying the levels of composite function. This first function that I have here is a two-level function. The outside level would be the quantity to the fifth power, and the inside would be x squared plus 4. For my second function, this would actually be a three-level function that I would recommend a rewrite for. So I would rewrite it as 3 times the quantity, the sine of 5x raised to the second power. From there, the levels of the function, the outside level would be 3 quantity squared. The middle would be the sine function, and the inside would be 5x. Now, for the rest of this, you're going to need a very firm understanding of being able to identify these different levels. If you need a little extra practice, I would recommend going back and rewatching the composite functions video again before attempting the chain rule. So let's look at both of the examples from the introduction. So again, this is a two-level function. I have my outside, which is to the fifth power, and my inside, which would be x squared plus 4. Now, what the chain rule enables us to do is look at the different pieces and kind of isolate those, take the derivative of them, and then we put everything back together. So for example, on this, I'm going to start by taking the derivative of the outside function. So anything to the fifth power, I take the derivative by bringing the power down and going to one less power. Now, right now we don't have anything in parentheses, and the reason we do that is because we don't want to be thinking about what's in parentheses when we're taking the derivative of the outside, because that's not our focus. But as soon as I do take the derivative, I'm going to put the original function right back in, okay? Because all I've done is taken the derivative of the outside. In my next step, I'm going to take the derivative of the inside. The derivative of x squared is 2x, and the derivative of 4 is 0, because 4 is a constant. My final answer I get by multiplying these two pieces together. I want to have one numerical coefficient, so I'm going to do 5 times 2x, which is 10x, and then I'll have x squared plus 4 to the fourth power. And that's my final answer, where there's really no way to simplify other than expanding, which would not help us really in any way, so we're going to leave it just like this. Now let's look at a slightly more challenging example. We've got y equals 3 times the sine squared of 5x. Now, remember in the introduction, I think that you need to rewrite this in order to be able to better see the different levels. Because this squared right here, it is talking about everything right here. Not the 3, but everything else. And I think this rewrite helps you to be able to identify and see that a little bit better. And it also helps us see our levels. So our outside level would be 3 times the quantity, whatever's in brackets, squared. My middle would be the sine, and then inside would be 5x. Now I can start by taking the derivative of each piece. So the derivative of the outside, I bring the 2 down out front and multiply, so I'll have 6. I go to 1 less power, which would be 1. I won't write that in my final answer, but I will for now, just because it's important that we recognize what happened to that 2. It went down 1. And then whatever starts in brackets stays in brackets. So it goes right back in. That's the derivative of my outside. Now the derivative of the middle, derivative of sine is cosine. And again, whatever starts in parentheses stays in parentheses. Because again, we're just focusing on one piece at a time. We don't change the rest of it. Lastly, the derivative of 5x is 5. So I'm going to find my final answer by multiplying these three things together. I want to get my one numerical coefficient, which 6 times 5 is 30. And these next two, the order really doesn't matter. I'm going to do the sine of 5x and the cosine of 5x. Notice I didn't do the brackets here, which I could have, but it's kind of unnecessary and it just makes it look a little more complicated than it is. So this would be my final answer for the derivative.